Hello everyone, welcome to a Java tutorial on how to make Pong. What we are going to use for our IDE is IntelliJ, but if you're new to programming and you don't want to, and this looks too complicated, then what I would suggest is to use BlueJ. BlueJ is very beginner friendly, and I actually use it quite a lot. It's a very simple design. You don't have to worry too much about anything, and one of the benefits of BlueJ is you don't get lost in it. It's just boom, it's just there. So as you can see, I got this. If I want to make a new class, I'll just say new class. If I want to make a new package, just click new package, just give it a name, and off you go. If you don't have Java yet, then go down and click the download SDK and get the latest Java edition. Now, assuming you've got this now, and that I'm assuming you've got a integrated development system, and that now we can begin our new project. So first off, you need to create a new project. Create a project. If this here is empty, then you go to New, and you select the JDK file that you want for that project. Click Next. Click Next. And now you get to name your project. So let's name our project Pong. Click Finish, this window. And there we have it. But now we can't click anything. So what we need to do is we need to make a class. So we open up Pong, we click SRC, right click, New, and then we press Java class. Now we're going to be using Java Swing and a little bit of AWT or AUT to create Pong. So anyway, we're going to call this Pong frame. And there you have it. There's your first class. What is this down here? Doesn't matter. Okay, so now we just got to import some classes in. Import Java X dot swing dot JFrame. Now, if I remember correctly, this is all we will need. Now we got to extend that. Make a class method. So Pong frame. Set the size of the frame to how we want it. So I'd say maybe 500 by 500 would be pretty good. Now we want to be able to see it, so we set it to visible. We just say true, and there we have it. And now if we want to actually run it, we gotta call it within the main method. And now we go new Pong frame. Now then, if we try to run this, it should pop up with a little window that has nothing in it. Nothing too exciting. There we go. So now we got something. We got an empty screen. Yay. Now then, I'm going to go in a little more depth here. So then, I used extends JFrame, extending the JFrame class as a bit of a shortcut so that we don't have to make a new object. What do I mean by that? I'll show you. So let's say we deleted this. Now we don't have any more. And let's say we deleted this. So now we're going to make a new JFrame, so we call JFrame. Let's call it just F as a shortcut, because it will get tedious to write it over and over again. Equals new JFrame. So this calls the class JFrame into an object. So now we go f dot set size by 500 by 500, f dot set visible to true. And now if you wanted to run it, it should come up with the same. And there you go. But for now, for this, I like to keep it just a little more simpler, and I just like to extend it. Okay, cool. Now what we're gonna do now is we're gonna make a new class. So we're gonna go ahead in here again, Java class, and we're gonna call this Pong panel. Now we're going to import this Java x dot swing dot JPanel. Now we're going to extend it as well. Extends JPanel, and make sure it's 100%. The word is 100% accurate. Now make a class method public Pong panel. And we want our panel or our canvas. Basically, how a panel differs from a frame. A frame sets up the boundary to what you can see. So think of a paint canvas. The JFrame is the frame of the canvas. The panel is the actual content on that canvas, if that makes sense. So now we set the size of it to the same, 500 by 500. We set it to visible, to true. I forgot to do something very important. I'm just going to copy and paste this down here. Now go ahead and type that down. This is pretty important. From what I remember, once you close the program that you're running, in the background, up front it closes, but in the background it's still running. So once you set the set default close operation, exit on close, it closes on the background. It doesn't take any of your resources. So now, once you type that, come back to pongpanel.java, and we want to import something else. Now we want to import the Java graphics, but we don't know what sort of graphics we want to use just yet, so let's just import all of it. Typically, I would say don't do this, but this is a beginner project, you're learning, and it doesn't really matter that much, in the beginning anyway. So let's now make a new method called that allows us to draw on the screen. So public paint, public void paint, paint component, graphics. We're going to call a class that we imported from the Java RT into this parameter. So graphics G, and we want to set the background of our JPanel to black. Color dot black. Oh, what happened there? Okay, now if we run this, you're going to notice that nothing's going to happen. There will be no changes. So what we got to do is we've got to call Pong panel over here. So now we got to add new Pong panel. Now this is just a shortcut, but I'll advise you, since you're beginners, to do it, to instantiate it like this. So Pong panel, and we'll just call it P. So this is the variable name, this is the class, we're calling the Pong panel class into an object, equals new Pong panel, and we want to add that, add P. So once we run this, there should be a black background. Well, okay, what's going on here? So what's going on? Why isn't it working? Well, because what Java Swing does is that it doesn't update anything. So basically the screen's going to be the same because it doesn't update. It's a little more technical than that, and it's better to understand it visually. But we got to add super.paint component, and we're going to call our argument variable G. And now, when we run it, it should work. Wonderful! Now we got a black box that doesn't do anything. So, hopefully you've called your object like this and not like this. I highly advise you to do it like this from the beginning, just so you can get used to it. Because it's this and this, they're essentially the same thing, that it's just that this is stored as a variable and this is just called. My cat's calling me from the outside of my room. Now then, we want to add some panels and we want to add a bowl. So let's do that. So let's make a public void bowl. And we're going to call graphics on it. and we just want to bowl somewhere in the middle of the screen. So I should get the correct dimensions first. So let's set the size to 800 by 700. This way, it's just easier for me to teach you guys since I've already done it. So now we want to make a bowl appear somewhere around the middle of the screen. So we got G set rect, and somewhere in the middle of the screen about 400 by 400 roundabout, and we're gonna make this, how big is it gonna be? 20 by 20. Now it's gonna say cannot resolve method set rect int. And the reason for that is because I called it wrong. It's fill rect. Now what is it gonna fill? It's gonna fill it in with, I think, a color of gray, but I could be wrong. But first, if you want to display it, we need to call it in the paint component method. So let's call this method into let's call the bowl method into the paint component method. The reason why we do this is that so if we have a problem, we can go, oh, it's from the bowl method, and we can focus our attention there, and it's more easier to read. The compiler and the Java virtual machine, it doesn't care about any of this. So now we go back to the Pong frame and we run it. And what color do we get? Yep, so we get a dark gray color. So what we're gonna do is we're gonna change that. Gonna go g.setColor color.white. Nothing too shiny. Now then, what we want to do is we want this bowl to move around. Or at least we want it in the future, we want it to move around. So we'll do that just a little bit later, but for now, public, let's add the panels, public void human player. We're going to call the graphics as a parameter. And now we can just go g.fill rect. And now, how large do we want it? Well, we want it by 25 in the X direction and 100 in the Y direction. Just trying to find a human player. Is that it? No, that's definitely not it. Oh, here we are. Public void player. So we called a variable here. Anyway, we want to set it to 50 first, and that will probably be, the Y direction will probably be somewhere in the middle, so 400. And it would be, what was it again? 25 by 100. But now we want the AI on the opposite side. So we go public void, let's call it a robot, because it's going to be pretty basic. It's only Pong. Graphics G dot fill rect, and we want it to be the equivalent but on the opposite side. So we got 800 in the x direction, so we just go 800 minus 50, that's 750, and we want to set it in the middle, so 400, that stays the same. Now we got a 25 in length and 100. I should also demonstrate, I just realized this, not Notepad, Paint. If you're learning Java, this is how Swings draws its object. So we got 50 by 100. The coordinates start at the top left. So this is where the x and this is where the y is. And when we do its width, its positive width goes in this direction and positive y goes down. If you're into maths, you're going to know that this is going to look weird, because usually that's a bit large. Because usually you think of a map like this. But with computers, it's the opposite. So with computers, up is negative and down is positive. Now, since the reason why I brought this is because we want the human player and the robot to be in the same spot, of the roughly equivalent of the same spot, but on opposite ends. So what we're going to do is we're going to subtract 25 from this again to 725. And now if we run it, well, no, actually first, before that, we got to call it. So we got to go human player and robot G. So now when we run it, they should be on the opposite end but equal to each other. So yep, there we are. Now you'll notice that there is a slightly bigger gap for the human player. The Java Swing is I don't know, so a little bit wonky with its dimensions. You'll note, like, once you program more stuff, you're gonna notice that some things creep out and sometimes they stay in. That's just how Java works, and it is a little annoying, but that's just how it is. Okay, so what we want to do now is we're going to import some more libraries. So we're going to import java.ort. We're going to call a event listener. We're going to call event.action event, and we're going to import a action listener, and we're going to implement this into our Pong panel class. So implements action listener. But now you'll notice that there's a red line. Why is it giving a red line? Because class Pong panel must either be declared abstract or implement abstract method action performed with the argument in the parameter as action event. So now, what does that mean? Well, it just means we've got to call a specific method to our class. So now we're going to go down here, called public void action performed, and this is, it has to be specifically like this, action event, and we're going to call it E. And now you're going to go up and you're going to notice that it's gone. So we just solved a problem. Yay! Now then, it's important, don't ever forget this. Once you're debugging and you're like, why isn't my program working? Make sure you add a repaint here. You're going to think, why is this important? And I'll go on to that a little more. Actually, no, I'll go on to this now. Once a frame or an action happens, it makes sure it draws it so that a new event is happening. So for example, if you press down on the arrows key for this to go down, if you had not called repaint down here, this panel here, it will just stay. But now that we've called repaint, it will go down or up. So that's useful. Now then, what are we going to do next? Well, that's a very good question. Let's just import a few more necessary classes, packages. So java.auth.event, and we're going to get KeyListener. So we're going to get a KeyListener, and that takes inputs from the keys we press, like up and down, WS, and allows it to be understood by the computer. So java.auth.event.keyEvent. So now we're going to implement this as well. So just put a comma there, and we're just going to call KeyListener. And now we got that red line again. So we're going to call a few more of those public classes. I'm not going to type this out. I'm just going to copy and paste this because it is a little tedious. Copy and paste, there we go. And let's just delete this bit here. And yay. So cool. Now I don't have this red line here anymore. I don't have an error. I'll just go down here so that you can type it down. Key pressed. Once you press a key, it's a little abstract by what it means by this, but once you program a bit more, you'll understand what it means. So once you press a key, it will do a certain thing. Key types, key press, they do, even though they seem like they mean the same thing, they are a little different. Key released is very useful, and I'll show this in just a little while. Okay, cool. So now, when we run it, you're going to notice that we haven't really changed anything. Yep. So we haven't changed anything. So that's a little boring. So now we're going to instantiate did I say instantiate? I meant initialize a few variables for the ball, human player for this here, because this is the x coordinate to where it is placed. The y coordinate, I'm sorry, this is the y coordinate. So x, y, width, and height. So remember that. the x-coordinate to where it starts, the y-coordinate to where it starts, the width, and the height. And remember that the width goes to the right direction and the height goes down as a positive, respectively. So now we're going to initialize a few variables. So what we're going to do is going to go int, and we're just going to call player. Let's call this player y. Int player y equals 400. We're going to initialize, what should we call this? Robot y? Let's call this robot y equals 400. Player y, robot y. If you're wondering what these things here, that's just some, how do I call this? They're just arguments, really. So that you know what you're missing and whatnot. That just helps to understand the method. Cool. So once we run this, we will see that there has been no change. Now then, you might be wondering, what is an int? An int is just a integer. It can go from a really large, or should I say a really small negative value. So I can make this negative, and that is very useful, as you will see. Or it can be a very, very large positive value. So I can make it like this, and it will still accept it. Although, of course, once we run this, it will be off the screen. I should probably ask you to change it just to see what will happen. So now we run it, and you're going to notice it's off the screen. It's not there anymore. It's gone. Cool. So now we're just going to change that back to 400. Now, and of course we want a x and y variable for the bowl, otherwise how's it going to move? So now we're going to call int bowl x. That is going to be equal to 400. Going to put a comma there. Bowl y is going to also equal 400. Going to put spaces before here because this is later going to get complicated. So initializes player variables. We should probably say initializes and declares. If you don't know what this means, this is just a comment. The compiler in Java Virtual Machine totally ignore this. It does not affect your program on the computer side. It just makes it easier to understand for the human reader. So I'm just going to copy this essentially, but call it robot. Same thing here, but say bowl variables. Cool. So now we know what these do. And we've grouped them together. So let's just comment our code just a bit. So this is called a class method. It's called a class method because the class is called Pong panel, and we're making a method down here, so therefore it's a Pong panel. Now you might be wondering, what are methods? Methods are just essentially this, something that you can call upon inside your class. So bool G, so bool is a method. Human player is a method. Robot graphics G is a method. I got to be careful with naming this because there is a Java auth class called robot, but I haven't called that in yet. However, this is not a class. This is called an object. An object is when it calls something and assigns it. It's a little more abstract and somewhat difficult to explain. But we called the Pong panel class, and the variable p is now an object. And set size is actually a method of the JFrame class, or the JFrame object. So hopefully you understand a little more what a method and object are. So we're just going to call this a JPanel object. No, that's not right. Let's call this a Pong panel object. Are there any more objects that we called? I don't think so. I don't believe so. So we made a class method. This allows graphics to be shown on screen, and this allows code to be executable. Not executable as in dying, executable as in running. So cool, it just did that. Now then, what should we do next? Well, I think moving the player would be pretty useful, right? So let's add in some parts to Keypress, because that's where I placed it initially, so I must have figured that key typed was not what I wanted. So let's go ahead and put it into Keypress. So we're going to call a code. So we're going to call it int code equals. Now, I should also, since we're learning Java, I should also explain that int code can only be accessed in the Keypress method. So if I was going to call it, for example, here, it's not going to work. Cannot resolve symbol code. However, if I was going to put the reason why player Y and robot Y work is because they're called global variables. They're not inside any method. They're inside the whole class, if that makes more sense. And just before I do that code bit, I should probably put bool X here and put bool Y here. So awesome possum. Now then, we want e.getKeycode. I believe it's e.getKeycode. I hope it is. E.getKeycode. Yep, awesome. Now then, we're gonna do a new thing called an if statement. An if statement makes it so that if something is true, then it will execute. Otherwise, it will totally ignore it. So, if code is equal, double equal sign is a comparative. So it means if they are the same value. So like if 1 is equal to 1, that will be true. However, if you say 1 is equal to 1, then you're saying 1 will be assigned to the value of 1. But anyway, I think I'm confusing you now. So code equal to key event .vkw. Now what this does is that it allows me to press the W key on your keyboard and allows something to happen. Now we're going to call an else if. We're not going to call an else because otherwise it will just go down if we don't press up. So else if code is equal to key event of vk underscore s. And now we're going to put some code in here. But first, before we do that, I believe we should probably do something. And we're going to call this player v, which stands for player velocity. Called player v, and we're going to call that as 0. And we're going to put it here, player y is going to be equal to player y plus player v. You can also abbreviate it like this. Instead of having to type player y equal players y plus v, you can just go do it like so. Basically what this does is it does the same exact thing here. It just takes this plus that. Anyway. Now then, we're going to say if the player wants to go up, then player v is going to equal -6. We want it to go -6 because remember, down is positive, up is negative. Else if the player presses down, or S, and player V is equal to 6. So, what this line of code does is that if the player presses down and player Y is still set to 400, then it's going to be 406 and then 412. But before we run our code, we're going to call something else. We're going to import JavaX swing, and we're going to call a timer. What a timer is basically a frame rate. That's basically what it is. So now we're gonna let's go up here. Let's see how I did it. Yep, new timer dot start like that. New timer. I would say, I don't know, something like 40. We're gonna say this. We're not gonna call that. We're just gonna go this. And what this does is that it listens to the action listener, or I should say the action listener listens to this. That makes sense. Don't worry about it too much. It's not that important. And once the Pong panel starts, the frame will start. But before we run it, we need to just add one more thing, and that is this. I don't think that was anything important. So add key listener. What this does is that it actually listens to your keys, and same with set focusable. So just type this down and all should be well. So I'll just give you a few moments to type that. Awesome. And now our player will not be able to stop once we press W or S. So as you can see, it's just going up, even when you let go. Once you press up, it just keeps going up. Once you press down, it just keeps going down. How can you solve this? Well, that is where the key release comes in. So if the player velocity is 6, going up, how do I fix that? Well, just set player V is equal to 0. So now once we run this again, you can see that now it actually stops. So that's useful. The frame rate is a little slow, so let's just fix that a bit. I set it to 10, so let's set it to 10. And now let's run it again. Awesome possum. But now you can see that I can go at the edge of the screen. How do I solve that? Well, it's quite easy. So we're going to go into human player. And we're going to go if player Y is greater than or equal to, is it greater than or equal to, or would it be less than? If it's less than or equal to 0, then let's just set the player coordinates to 0. I think that's how I did it. I could be wrong though. Yep, so if the player Y is less than 0, then player Y is equal to 0. Else, if player Y, now we want to do the same thing for the bottom boundary. So if player Y minus its length, I should say at plus its length, actually, plus its length is greater than, what did I set it to? 700 is greater than 700, then player Y is equal to 700. So now let's go run that. And as you can see, I can no longer, look what happened there. Oh no. Let me just run that again because I just decided to disappear. Ah, I know what happened. 600, of course. So now we run this again. And as you can see, it does that weird thing. Where that, even though I set the boundary to 600, it still goes in just a little bit. This is what I was talking about before, where Java Swing was a bit weird with its coordinates. But that's okay, because what we can is make our own little boundary that extends it. We just need to be a little more careful. So we're gonna go g dot feel rect g dot feel rect. We're gonna start at where x is 0, but we want to go at the bottom. So let's go to let's go for 600 first. So 600, and we want it to extend the whole thing. So 800 by 100. Yeah. So now we can just compare it to this. Although I don't like how thick that little wall is, so I'm just going to look as to how I did it up here. So I did it by 0, 600 by 20. Yep, so as you can see, it still goes through, but that's okay. So now, we've got to make a comparative for 600. So let's just go down and change that a bit. So if that's 600, then this is now 500. Because 600 minus 100, which is the boundary, sorry, this is the player Y, subtracted by player length, which equals 100. So now once we run that again once more, sweet, now we don't go over the barrier. But now let's add a little bit of some new things. So let's make the ball actually move. That'll be fun, right? I think that'll be fun. So then, I'm just gonna look in here. Yeah. int bowl angle Now how did I do that? While spawn. Ah, yes, okay. So we're going to learn a new thing that's called a boolean. Although you should already be familiar with it because we've done it with our if statements. So boolean can only have two values. That's true or it is false. So anyway, boolean, and we're going to call this spawn, is going to be equal to true. Let's go down to bool. So while true, we want it to spawn in here. This is going to look a little complicated, and I'll explain it in a little bit. Okay. So if you don't know any math, this will look a little frightening to you. Okay. So I'm going to teach you a little bit about the unit circle. So then, that's horrible. Let's actually get a line. Oh, my OCD is kicking in. Okay, there we go. And now we're going to go all, sine, tan, and cosine. And we're going to go 0 degrees, 90 degrees, 180 degrees. That's a terrible 8. Doing this on mouse isn't the best thing. 180, 270 degrees. And this can be 360 degrees. So 0 or 360 degrees. They're basically the same thing. Right. So sine compares the y value. Sine is only on when S here, when the angle is from 0 to 180. Right? So it's only on here. It's only positive, I should say. It's only positive in these quadrants. I won't teach you about tan because we'd never use that until much later, till where we have to calculate where we want the bowl to go for our robot. But that's a little later. Cosine is only positive when the angle is somewhere from 270 to 90 degrees. So that's cosine, and this is just sine. So S, T, and C, they're always all true when they're in between 0 and 90 degrees. They're all on. But S is only positive outside of A when it's between 90 and 180. So hopefully you get that idea. So what we want to do for our Pong bowl is we want it to sort of go in this direction, this direction, this direction, and as you guessed it, this direction. So we want it to spawn somewhere in here, because we don't want it to go up. That would suck quite hard. So this is what this if statement does. Now you might be thinking, what does a while loop do? Well, as a loop, what it does is that it just runs through thing. It just continues running forever, unless something happens. Now then, we're going to probably call this spawn. There we go. So spawn is set to true, but once this if statement is run, spawn is false, and therefore the loop that goes on forever stops running forever. So that's useful. You always need a way for the while loop to stop, otherwise it will just break your computer. I'm joking. Unless you leave it alone, then it will actually break your computer. But you have plenty of time to fix it. Just exit the program as quickly as possible so it doesn't damage anything. So, angle, put it in here like this. Angle is less than or equal to 45. I'm just gonna get this. Oh, is there a better way to do this? I don't think there is. Maybe if I show it down here, maybe? Yeah, there we go. So angle is less than 45, so it incorporates this bit here, or the angle is greater than 315, which incorporates this. Now what an OR statement does is that if this or either that, so if that or that, then true. So I'm gonna probably also have to explain what an OR statement does. So an OR, so if I say A or B, I'm gonna draw a little truth table here. Sorry. So we got A, we got B, and then we got A or B. So we got 0, which means false, and then we got 1, which means true. So A or B, so this will be false because they're both false. So false or false is false. False or true is true. True or false is true. True or true is true. So that's a quick understanding to OR statements. Now I've got to bring it back down here. So or angle is greater than 135, sorry. So this bit here is 135, and angle is less than or equal to 225, which is this bit here. The reason why it's an AND is because it incorporates only this part here. The reason why we didn't put an AND symbol there is because one of them is 45 degrees and the other is 315. So I use the AND symbol in this case to like sort of make it like it's in between these values. But with the OR statement, it's anything less than 45 degrees or anything greater or equal to 315 degrees. And this is what I was talking about in my video before, where I had some trouble with my angles because of this. Anyway, so bowl angle equals angle I do believe we've already declared that. Yes, we have. So here is a method variable that's only accessible for bool. And now it runs through that. And now we've got bool vx or bool vy. So what we're going to do is we're going to make new variables called bool vx, which is bool velocity in the x coordinate. And that's what it means. So int bool vx and int bool vy. Now then, I should have also explained that it's good practice to initialize these as 0, but for Java it doesn't matter. Once you get into C, you will have to sort of assign it with something, but I won't worry about that for now. You're not learning C, you're learning Java. So make sure your add spawn is equal to false, otherwise you're just going to be in this state of loop that goes on forever. Now you're going to notice that nothing really happens, I believe. Oh, what happened? Times unispeed. Unispeed? Yeah. Now what a unispeed is that I just sort of made it so that it's more comparative to everything else. That may not make much sense at the moment, but I sort of made it so that whatever unispeed is, if I wanted to change how fast the Pong and the ball was moving, then I'll just change unispeed, but I wanted the paddles to be slower than the ball, otherwise it's not really there's not much danger. So that equals 8, I believe. And now, I think once we run it, we should be all good. Yep, so you'll notice that the ball doesn't move as expected. If we remove this line here, don't do this unless you want to, but I prefer if you don't, because I don't want to be blamed. But anyway, I'm going to run it, and you're going to see what happens. It's just going to be, yep, that's just going to happen. And your computer's going to run really, really hard. And as you can see, I can't close it. So I'm going to have to go into Task Manager and kill it. IntelliJ. Oh no. What has Windows done? They updated it. Okay. So Windows gave an update to where all of this has changed. And I didn't know they had changed the Task Manager. So this is going to take a while. Okay, so yay. I'm back. And now I'm going to make this here again, so that now that it works. Can I even English? I don't even know anymore. So once I set spawn is equal to false in there, it can now run, because the while loop doesn't run forever. It's not stuck anymore. So that's the dangers of a while loop. There is another called a for loop, to where you know to what number you want to loop it as, but while loop are useful for when you don't know the amount of times you have to loop through something. That's where a while loop comes in. So remember, a while loop, it runs through all of this and if it's still true, then it runs through it again. If it's still true, it runs through it again until you either call break. So if I were to call break, this program will be fine. It will still run because I'm breaking the loop. But we only want this while loop to run when we need to spawn the ball. Okay, now we need the ball to move. So now then we just go, I believe, from my understanding, we want just ball x is equal to ball x plus the ball's velocity of x. Ball y is going to equal ball y plus the ball's velocity in the y direction. Now hopefully, once I run this, we're going to see the ball actually moving around. Yay! The ball moved. But it didn't spawn back. So we're going to have a few if statements. So we can go if, actually we should probably, let's do it underneath it. So if ball, if the ball of x is less than 0, then spawn is equal to true. Else if ball is greater than 800, actually no, let's go 800 minus the ball's width, which is 20. Then we want spawn to also be true. But we're not done there, because we want the ball to bounce. So if the ball y is greater than or equal what was it? Yeah, that's right. Less than or equal to 0. Let's just say less than. Yeah, less than. Less than makes more sense. Less than 0. Then ball y is equal to negative ball y, so that it goes in the opposite direction. This is going to be part 1 of this video. The reason why I did it into part 1 and part 2 is that the first part is the simple way of doing it, simple version of Pong, and the second part will be more complicated and it will involve more angles. So else if ball y is greater than, now remember we set a boundary. Where's our boundary? It's at 600. Is greater than 600 subtracted by the ball's height, which is 20, then we want it to go in the opposite direction. Now I can see the danger of this already with the ball just spastically keep going in opposite directions. But let's see how it goes. Okay. Java cannot find variable ball. Well, that makes sense. I don't know what's happening here. I'm gonna do something a little differently. Okay. I think I know what's going on. What I'm gonna do is that I'm just gonna invert. No, that wouldn't work. Okay. Fuck. Ah. So first, I'm just gonna say, yep. So I figured out what the problem was. Got to be careful with these sort of things. Okay, for first, I'm just gonna change this to that. I believe 315. This should also be 315. This would be 365. And now, what did we do wrong? What we did wrong was this. We need to actually place it there ourselves. I thought this bit here did it. It's been a while since I had a look at my code. Yep. So, once we run that, the x coordinates should then spawn in the center. Yep, now look at that. So now it keeps spawning, so that's nice. But now what we want to do, we're nearly at the end of the video, so what we want to do now is we want the player and the robot to actually hit the ball. So what do we want? Do we want, when the player hits the ball, do we want it to just reverse the angle so that if it's coming down like this and it hits the paddle, it goes down like this? Or do we want it so that once it hits like this, it goes back up like so? I'll say this one. It's a little more interesting. So we're just gonna, what we're just gonna do is just what we're just gonna inverse the x velocity. That's all we're gonna do. And that was probably why. So we're going to go, if ball weighs less than a 0, We're just going to set it to there. But now we're going to also go is opposite to itself. So let's just fix that. And the same premise here, really. Except this will be 580. So once we run it, if it hits the ground, it should just bounce up. Yep, there we go. Awesome, sweet, fantastic. Now then, our ball method is getting a little bit large. And typically, you don't really want your methods to be large. If it's going to be large, you may as well make a class. But this is a beginner project. It doesn't matter too much. Who cares? You're having fun. I'm having fun. So mistakes like this can happen. Cool. So now we need to add it so that if it hits the paddle, human player or robot, it goes in some direction. So I'm just going to look at my little cheat sheet here. Now I made my Pong game just a little more complicated than it had to be, which is why it looks all nasty and gross. I made it so that there was like a little bit of randomness, but like it was calculated random. I don't know, difficult to explain, and we won't make it like that because it was really hard and it wasn't really that great of a feature. Now then, see, this is where comments come in handy, because I have no idea what is what. But I'm pretty sure this is what I want. So if ball of x is less than or equal to 50 plus 25. I do believe this is right. Jesus Christ. I wish I hadn't done that. This is so dumb. I'm even having trouble understanding my own code I wrote like a month ago. The video came out 2 weeks ago, but I was a bit busy, so it took me a little while to edit that video. Jesus Christ, I can barely understand this. This is where comments come in handy. So remember, once ball of x is less than 0, so hits left frame, respawns. Because that's exactly what it does. Hits right frame, respawns. Hits top frame, goes down. Hits bottom frame, goes up. Oh, dearie me, I can barely understand this. So if ball of x is less than or equal to 50, sorry guys, I'm a bit sick, which is why I haven't made a tutorial for my video. I've been sick for the past 2 weeks. It's been hell. Less than or equal 50 plus 25, and the ball plus 20 is greater than or equal to 50. Okay, I need to draw this out. I'm actually having trouble understanding my own code. Okay, so what do we know about this? Let's just make this black. And let's make this a square. No, a square. Is that a square? That's a square. Cool. So what do we know? So by its width, which I'll just call W, and its height, I'll call this 2, because we got this one here, so I'll call this 1. So it's 20 by 20. Oh god, my voice is a little croochy. What is the width? The width, I'm pretty sure, is 50. And its length is 100. Okay, so for now, let's just make it so that it only hits this line here. So what we want it to do is we only want it to hit this length here. So from what I can see, that is what I have done. So 50 is less than or ball x is less than or equal to 50 plus 25. 25. Where did this 25 come in? Hang on. Oh, okay. Okay, so I was wrong about that. It's 25. God damn it. 25. So basically what this is, it's where the paddle has started, 50. So 50 plus 25. So if ball is less than 50 plus 25, which is this bit here, but it's also, so if it's less than that, but it's also greater than this left bit here, which is what I've done, I do believe. Yes, I have. And the ball of y, and basically what this did is just, it's inside here. So go ahead and copy that. Now then, what do we want to do? We just want to make it so that the ball of X. No, sorry, we want it to be ball Vx is just the opposite to itself. And we want the same thing to be said about the robot. So else if, I'll just go ahead and copy that, and then you can just copy me. It's the same principle, just different numbers. If I can find it, of course. Yep, here it is. Now we don't want an else if, we just want an if. We want it to be its own standalone thing. This method is spaghetti, but whatever. And we just want it to be the opposite of itself. So, robot Y, I believe. Yep, robot Y and robot Y. So just what have I done? Yep, so just copy these 2 lines of code. Now let's see what happens. Hey, hey. Oh, that's a little wonky there, but that's easy to solve, I hope. So this is why you want to add angles, because if you don't, something like this just happens. It's just straight. But it does get a lot more complicated as the game goes on. So this is the basics of it, but for now we want to correct this bit here. So what's happening there? Well, it's obviously from the x-axis, so let's see. And I've done this backwards to what I've done it there, so that's helpful. Seven ten. Ah, that's right. Yeah, I know why that's different. So if I go here and I go to robot, yeah, 710. So we just want to change that to 725, and all should be possum. if it actually hits it. Can you hit it? No, never mind, we haven't solved it. Okay, what's going on? Why isn't it working? Maybe because of this. Okay, now let's try it out. That was my bad. Hit it. There we go. Cool, so that's working. So now we get to the AI part. It's a very... I won't even really call it an AI yet. Once we've done it, it wouldn't even still be an AI. How I define an AI is that it creates a situation to which you should respond. And it can predict human behavior. Right? So it can create its own scenario of events. That's what I think an AI should be capable of. Ready. So we just go in here, click New, Java class. Let's call it. Let's call this a Pong robot. Cool. And we won't have to actually add or import any classes, I believe. But we will need to import this here. So what we do is we go int public static. Can you get away with that? I think you can get away with that. So now we just got to call the Pong class. So what we do is we go int robot y is equal to Pong panel dot. Now then, I've sort of left a little clues in my class. What I did in my method was that I made them all public. So if I wanted to add them, I can go public bowl, for example. You don't want that. It's best to keep these, the ones you don't want to use, private, like so. I never actually set public paint component to private, but I guess it won't hurt. This should be kept as public though. So get that. That should be changed to private. That might need to be private. I don't know if these guys accept to be private or not. I haven't really experimented with that, but it should be fine like it is. So Pong panel, and we're just going to call robot y, and that should be fine. If we try and debug, if we can, where's our debug? There it is. Debug Pong frame. No, we don't want the Pong frame. We want I give up. So now then, we're going to call a private. Let's call it private for now. Private int. Yeah, I'm pretty sure I'm going to use this. So public int move blah blah blah. In fact, now that I think about it, we may not even need this here at all. My cat is outside meowing at me. So for now, let's just return 0 so we don't get any error messages. In fact, yeah, actually, let's, I don't know, let's do it like that for now. Let's call it int robot y. I don't think we're gonna ever use this. So then, how am I gonna do this? Because we want, for now, all that's our quote-unquote AI can do is just follow the ball. That's all it can do. In fact, let's probably say public int get y. Let's call this robot get y, actually, because I know there's an already get y there. Call this int robot y, and we'll call this robot x. X, y, yeah. So ball y. There we go. All this does is just it returns robot y. That's all it does. So if robot get y, actually no, let's do this the opposite way, just so you can get the hang of it. So if the ball y is greater than robot y, or robot get y, I'll just make a variable here, and we'll call it, we'll call this move. So int move, where it can only be, I'm gonna try something out. Int enum move is equal to 6 or -6. I believe that works. Hang on, let me just search it. It's been a while since I used enum. Now you might be wondering, what does enum does? What enum does is that it only allows it to accept certain conditions. Now from what I'm seeing, you don't actually, okay. Is that okay? Oh, I don't know. I'll have a look at it later. So will just be equal to 0. So if the ball y is greater than robot get y, that means we have to move up, which means I have to close Google Chrome because it's killing my computer, which means we have to go negative. So move is equal to -6. Else if the ball of y is less than robot get y plus 100, and I just realized, and the silly error that I just made. Whoopsies. My brain's having too much problems today. Yeah, but anyway, we have to plus 100 because we don't want it to really keep moving all the time. We only want it to move if it has to move. But let's just make it so that it's sort of in the center, so is greater than, I don't know. Let's just keep it as it is. It doesn't really matter. Then move is equal to 6, return move. Now then, what was the problem I was having? Well, I'll have to call robot get y. So, pretty much, yes, I do need this. But I don't need to make this public, I believe. Oh, how do I change that? I don't know how to change that. Doesn't matter. Yep. So now that calls that, and we got a robot return robot y, which is not what we want. We want a. This is what we want. I can get away with this, but I forgot which this refers to. So let's call robot get y. So now robot y is equal to robot get y. And now we can do a little shortcut to replace this. So we can go robot get y, and I believe we can change it quickly. Maybe not. I haven't done this in IntelliJ. I give up. God damn it. What I was gonna do is that I could just find all the instances of robot get y, the method, and just replace it with robot y. That was all I was gonna do, but I couldn't find how to do that. Cool. Now then, do we have any issues? I mean, sort of seems like we do. Right, we don't have that anymore. So we're gonna go int robot y is equal to none of that. But once we call the move, I don't know, it'll come to me. I'm doing it differently than when I did it in Pong, because I didn't do it like this initially. I had a goal to what I wanted to do, and I didn't really have any troubles with it. Right now, I'm just improvising. Yep, okay, so now I found a way to do this. So basically what we do is we just totally ignore this. We don't ignore it, we just copy. We get that. And set y. I don't think we need this anymore, to be honest. So we got public int move, and that returns move, but we also say robot y plus move. And I'm pretty sure that's all we have to do. So now let's call the robot Pong robot object. So Pong robot. Let's just call it. What would be a good name for it? Let's just call it Jeff. Let's call it Jeff. No, I'm kidding. Well, Jesus, what would be a good name for it? Let's just call it a robot. So robot. Apparently there's already something called a robot. No? Okay, I guess not. The Pong robot is equal to Pong new Pong robot. So now, cool. A new Pong robot object. Robots. We just got to add this together, otherwise it will keep changing. So robot plus y plus or equal to y. That's right. Let's do it this way. Plus move, and let's just return robot y. This doesn't need anything. Public set y. No, let's go public void. No, int return robot return y. In fact, no, let's name it something better. Robot get y. So robot get y. I think I already named it like this. Whoopsies. And it will just return the robot y. Just in case we need anything for that. Yeah. So we'll go robot dot robot get y robot dot robot get y, and I don't think any of that will change. Oh, get y. There we go. Yep, I'm thinking that's all good. Now we just got to change this, and we just go robot dot move, and now we just run it. I think we should be good. Oh, what happened here? Bowl y. You're right. So let's just change that. Ah, okay. Yep. Into robot, not robot, bowl y. And I think all of our issues here are solved. Can't return robot y. Can't return it because I spelt it wrong. Okay, now I think I'm all good. And now we should have a, oh, never mind, he's gone. Okay, so what's happening? So what is going on with our little AI? Well, first, I think one of the best ways to see what's going on with it was that it will be to actually give it a few walls so that we can see what's happening. So, same thing here. Just copy and paste this. And we go robot get y and robot get y Now then, we're going to make a new method that allows us to set y. So int, should it be int public void robot set y return, not return, int set, and robot y will be equal to that set. Now I probably didn't go over it. What these arguments do is the method, when you call this method, the move method, for example, you have to give this number here a value. So what we gave it, so when we wanted to move it, we gave it the variable bool y. So we would compare the bool y variable. So it is what it says it is an argument. Now then, I totally forgot what I was going to do. Yep, okay, I remember now. Now we're going to set this robot set y to 0. You might be thinking this is a little bit complicated just for something this simple, and I do agree, but this is setting up for part 2 to where things get more complicated. To be honest though, I'm thinking that I should have just made a Pong video outright like this, because it would have been less confusing, but I thought this would be a good idea, but now I know that that's not the case. Okay, so once we run this, he should just stop up there. Okay, so why isn't he going down? See, I just fell into that trap. So if bool y is greater than robot y, I just fell into that trap. So we basically just want the opposite of this. And now once we click running, we got our little spastic AI. And as you can see, it's not really that much fun. It's not really that different. But part 2 of this video will make it so that the AI is more complicated and the game is more complicated. So I hope you guys found this video helpful. I did my best to explaining the concepts of programming and mathematical concepts that went into this project. Please like and subscribe for part 2 of this video, to where your AI can decide where it wants the ball to be hit. And I'll see you all next time.